Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this GFG problem of the day. Find rectangle with corner as ones. Okay, so let's move on to the problem. So in this problem we are given a binary matrix of n into m size. Like total number of row is 4, total number of column is equal to 5, and this is the given matrix. And we have to find out whether there exists a rectangle or square within the matrix whose all four corner are 1. Like here you can see this is a matrix. Sorry, this is a matrix, and here this corner, this one, like this part, first corner, second corner, third corner, and fourth corner. So okay, so these four corner, when we match it, like these two side, like this, and this side, and as like this side. Okay, I'm just showing you how. Just wait a minute. Okay, so this is the triangle I am talking about. This is the triangle. This is the triangle of size 3 into 3. Okay, so this is for what I am talking about. Okay, so how we are going to do this? I have printed this all in a whiteboard. So now how we are doing to solve it? We are using a N4 law because it is submitted and it is very complex type problem, not logical but just implementation problem. So because n raised to the power 4 is also submitted. Okay, because the time limit is also not given, and R and C are also uh, also only 200. That's why I think I should try NQR4, and it is submitted. So how we are doing this? First of all, my n is equal to size of the matrix, means the number of rows, and m is equal to the number of columns. Okay, then I run a for loop for each row, end to end. Like first I will do for it, then for this, then for this, and then for this. Okay, so now, and now in this row I will check for each column. Now what I'm checking for each column? Okay, now what if my Vij is equal to 0, means I just continue. Why? Because it cannot be the corner, it because my corner should be equal to 1. Okay, but if we found any one, then I have to found a second corner. Then for next column, for j plus 1 to m, I need to find a second corner. And if I found, if my that number is equal to 0, then I just continue because my second corner is cannot be equal to 0. But if this is equal to 1, then it means I found my two corners. Now I just need to find out my bottom two corners. Okay, then I run a loop for I plus 1 to n and check whether these two corners are 1, and if it 1, then I return 1, else I just return 0. So how we are doing this? Okay, so just suppose we are initially doing this loop. We are initially at this, my j is at this. Okay, my j at this, my I is at this position. Okay, this is equal to 1, so I will come in my k is equal to this. Okay, I will take some other color for k. This is my k. Okay, this is my k is equal to 0, so I continue. This is my k is equal to 0, I continue. My k is equal to 1, so I now I check out. You can see my vik is equal to 0, I continue. Else if it is equal to 1, then I just check out for these left out column from I plus 1 to n, whether these two index particularly are is equal to 1 or not. Then I will try for this. Not, this is 1 but this is 0. Here this is 1 but this is 0. So I don't found any rectangle with corner is equal to this and this. Okay, so I will come at this. No corner here exists, so we don't found any rectangle that contain two corner in my ith column. Okay, so now what I am doing, so now what I am doing, just a minute, just a minute. Okay, so now my I is equal to at this, my I is equal to this, my j is equal to this. Initially j is equal to this, is equal to 0, so my j will pass out is equal to 0, my j will come to this. Okay, now my j are come to this, it is equal to 1. So now my k, I will start my k, this is my j loop. Okay, I just write it down, this is my j. Okay, now I am taking a k, k is equal to this is equal to 0, so I just move out my k, this is equal to 1. Now I take a h variable for this particular, I will take my h variable. Okay, for h this is equal to 0, this is equal to 0, cannot possible, but for now this n minus 1th row, this is equal to 1, this is equal to 1. So you can see I found a column whose these four are equal to 1. Now how many columns this gap contain is does not matter, because these two are equal, these two are equal, and and these two are equal. Okay, so gap between these all are same, gap between these all are same, you can say this gap, this gap is same, and this gap and this gap is also same. So I just return true, I found and I just return true. I just compile it now, and if you don't able, like if it is equal to 0, then I will check for this, else while I will check for this. If I found any, then I will return 1, else while I just return 0. You can see here, I will try for this case also. You can see I will try for this case also. You can see no, because here it is like this, it is like this. Okay, input should be in order, so it is easy to understand. Okay, you can see here is not a single rectangle that can exist. And why not we are checking for square? Because every square is a rectangle also. Okay, so you can see problem is solved successfully. All 58 test cases pass out. Time taken is also very one. When I submitted it is equal to 0.0, but now it is showing 0.1. Doesn't matter because it should be submitted. Okay, so all test cases pass out, and this is a just you can reduce it to n cube, but for that you will need to take out another map, or doing a map, then it will increase the complexity of the code, decrease the time complexity, but increase the written complexity. But it is a very simple code now for n4. Okay, so I hope you will understand it. I am explaining you by example. I hope you all understand it, and if you have any doubt, then just comment, or I will try my best to explain you. So please check out my channel for more solutions of lead code and GFG. I upload solutions of daily problems continuously. So please like the video, subscribe the channel, and stay tuned. Thank you for watching this, guys.